Everybody hear me? So those who don't know me and haven't been participated in the VSF, VTrans, for the last 6 years, I have been a fixture. And today I'm going to talk to something that excites me. To those who don't know me, I'm being involved in reliable delivery, and I'm a proud member of the RIST activity group. And some of the things that you see in RIST coming from my brain. But today I'm going to talk about something different, completely different. Throughout this conference, we are talking about IP, transition to IP, going to the cloud, a lot of things to do with the cloud, and it is very exciting. But we're forgetting that there is one question that, when you go and do the work, troubles you. And that is, what is going on with my delivery network? What do I need to know? What do I need to learn? And this will be the topic of my presentation today. So, digital transformation is all around us. The broadcast industry is running forward with rapid adaptation of digital transformation to all its IP flows. And we see that today. The industry is moving away from dedicated fibers, MPLSs, more and more to the internet, cloud, those sort of things, for backhauling our content, whether it is compressed, lightly compressed, or uncompressed altogether. New reliable delivery protocols, RIST, SRT, NDI, WebRTC, QUIC, are coming and allows users to venture out to the new frontier and spread their wings. Cloud production and remote editing based on JpegXs, like we saw in the presentation before, 2110 is still challenging, but people will tell you they are doable. The delivery network is becoming more and more problem-prone than before. Old monitoring solutions and root cause analysis solutions are inadequate to take the new era head-on, and we need new tools and new solutions to take that. And what is the outcome is that more and more responsibilities are falling on the shoulders of the operating people, the broadcast people that needs to do the day-by-day operations, and they are falling short on that. So the question that people will ask, why reliable delivery is not enough? Is it not RIST, SRT, NDI is sufficient? And the answer is very simple. Those protocols are reactive to changes. They are great to deal with packet loss, jitter, reordering, figure out the latency, and if it's adequate enough and you designed it good enough and you configured that properly, they might work. They are all there to shield you against the network artifacts without knowing exactly what are those horrific artifacts, when do they occur, what are the trends, and so on. And my contention is that we need to know more about that. Okay. So we need to identify problems before they happen and try to avoid them if we can. We need to get to the root cause of the problem to make sure that we can tune our delivery solution and use the right network solution for our intended purpose. IP networks should be treated like a big ocean with currents and many users using them all together every day, every time, and from all directions. So for that, we need something new. We need something that I called it delivery intelligence. Now, for people that knows me from past presentations, they know that I usually tend to go to the military intelligence, but because Kieran said that he's going to be coming, I changed my presentation, and I moved from military intelligence to weather. It's not controversial. So there's no Iron Dome, and there was no other things to do. But there was. So it's not enough to go outside and see if the sky is blue. As you probably know, in the US, you have your mobile phones and you can check when the weather is going to change. Unlike the weather in Israel, that I never know what's going to be tomorrow. And look at how weather forecast has changed in the last 20 years. We now look from the sky on the weather patterns, the cloud patterns. We have stations to check humidity, pressure, and wind to forecast the weather. This is intelligence. We are gathering information, statistics about what is going to happen and predict what is going to happen and tell you whether you need a coat or you can have one layer of clothes. So we need to use intelligence for many applications. And we use that today. Look at the business intelligence to identify trends and possible customers. Look at seismograph, and I wrote the presentation before the earthquakes in my region in Turkey in order to predict earthquakes. Look at ocean buoys to predict sea currents, weather, and tsunami, and so on and so on. Our mobile browsers, TV use intelligence constantly to identify the user trends in the home and what they want to watch. So why not use intelligence in the IP realm to look at traffic patterns and let you know what is going on before it happens, while it's happening, faster than before, so you can react. Instead of reacting by switching after the fact, because you get an alarm, somebody does a switch, it takes sometimes minutes, maybe less. You need to know that in advance so you can prepare yourself and switch at the right time. So, going forward. So what is missing in what we are doing today? So broadcast solutions, like we have multi-viewers by esteemed vendors here that also have presentation down below. We have, for instance, we have TAG, we have Everts, Rozenberg, even Cobalt have multi-viewers that you can identify problems visually or by alarms that they can provide you. Don't get rid of those. We need them. That is the visual way we can know that there is a problem. We have the long ETR 290 compliance by way of BridgeTech, Everts, Elecard, that were the Boro product that we saw the presentation today. They can identify problems with our content and when it falls short. And we have alarm monitoring by way of Skyline, Everts, and others. That is what we do today. We don't have any tools to know what is going on in the network itself, what is happening, who is the bad guy, what is going on. This is something that is missing, and this is what I'm trying to achieve. So, as I said, they are focusing on content compression, transport packaging, and delivery issues after the fact. IT solutions. There's not many IT people here, but IT people would just jump like I would do and say, oh, we have solutions. We have solution by Thousand Eyes, AKA Cisco, an open source solution called Zabbix, SolarWinds, network performance monitoring, and Datadog to analyze alarms. Yes, but those are catering for the IT industry, and they don't cater for the video industry. The basic resolution that they have is that they can sample usually one packet every second. Well, how many packets do we run usually? 1,000, 2,000, 100,000 packets? Is that sample rate good enough for us? 1 packet a second? And what exactly do they measure? What they are focused on is the long-term network availability, application usage at slow sampling rate. Reliable delivery solution that I mentioned before, and we had Ciro talking about the RIST adaptation, which is a great step forward because now we can measure and have reports. They focus on error, jitter recovery, but have very narrow view because they only focus on themselves. RIST will report you on the RIST stream. If I'm going to have an SRT dissector, it will tell you what is going on with the SRT. It will not tell you about other flows in your network, whether they are making problems or are suffering because you decided to burst or you decided to do something which is wrong. And we need to know that. We need to get to the root cause of that. So how will video intelligence will help me? or you. We are focusing on what is missing in other solutions today. We want to gather more in-depth information on the network impairments that is key for the successful and consistent video delivery. We want to have more data points, faster alarms, faster trend identification, faster root cause analysis, and to be protocol agnostic. I don't want to have a solution for RIST, a solution for SRT. I want to have one tool that will test them all if I can. And I want to focus into looking into end-to-end delivery regardless of the protocol. I want to have system view of the multiple flows. When I say flow, it's an IP flow. It can be a stream. It can be data. It can be TCP flow, whatever. Because everyone can contribute to the problem. And I just need to know who it is, when it is happening. And I'm sure that people here with their experience know that you never mix file transfers with video streaming because file transfer usually likes to burst and take all the bandwidth what is available to it. I want to bridge the gap between the broadcast industry and the IT teams so we can quickly identify a problem, isolate a problem, and bring the IT people to solve it as fast as possible. And of course, testing the performance of any 2 points with a reference test stream for precise fault detection is, in my mind also. So where intelligence is needed? Video-oriented link evaluation before any transmission. If I'm going to do the Olympics, I want to test the available networks before I do that. Instead of what is done today, just sending a reference stream, I need to have more statistics because a reference stream doesn't give you information. It gives you after-the-fact information. I need to have a better tools to test the network. What are the points, operational points of that network where I'm prone to more latency, more jitter, more packet loss? I need to test that. I need to have a continuous stream delivery performance testing. While I'm streaming, I want to have that. Video path analysis to detect any path changes that are occurring, and that is critical as I found out on the internet and the cloud. I want to fine-tune my delivery protocol to the network condition. That is also an outcome of the intelligence. Now, instead of testing one time, doing an RTT test with a ping or whatever, I now need a tool that gives you an adequate and precise information about what is the latency, what is the jitter, so I can fine-tune my RIST protocol, my SRT, my NDI, and even WebRTC for some applications. Keep in mind, not all protocols are adaptive like the RIST and protocols that I designed in the past. So let's talk about link evaluation. How do I test the link before I go live? Okay, so things that I need to do. I need to do path discovery. What is the path? How many hops are in the way? Are there any dynamic path changes? A lot of people forget that. I want to ponder on this point. A lot of people will do a simple trace route between my point to the destination, find that I have 10 hops. I will do another test, 10 hops. I'm good. I see the RTT, I'm good. Guys, I did that. Whenever I have 10 hops, I usually probably will find 15. A ping test amounts to 0 in our industry. And please use this as a guidance for yourself. Don't use trace route. There are other tools to do that. Don't use the standard trace route. There's tools called MTR. There are Paris trace route. The other tools, trace route runs an ICMP. It's a ping. It's accelerated trace route, not suitable for the video industry. It gives you the false appearance of a good link, but it will change over time. And you have to check the link all the time. When you go to the cloud, you will be amazed the dynamic nature of your path. I can tell you that, and I can show you if somebody wants to see that the path changes almost every few seconds. And then packets again getting rerouted. you have load balancers, you have NATs in the system. They can be added, removed on a temporary basis in the cloud itself, and it's a nightmare. And you need to know about that ahead of time and while you're doing that. You need to see packet loss at every route, which is you can get it with a trace route. You probably would like to know who is the service provider that gives you the service. You want to have the RTT for each node or hop, and you want to know the overall TTL that will vary. Then you want to go to the next step. Test the network, or what we call speed test. Instead of testing it for the full range, you need to do that slowly, step by step. Why? Because every step has a different outcome. It might have different hops, it might have different jitter, it might have different latency, it might have different packet loss characteristics, and you need to know that. So that when you decide which bandwidth, which bitrate to use, you can correlate that to the test that you perform. Maybe you would want to prefer, instead of sending 20 megabit stream, you would prefer to send 18 because the probability of packet loss will decrease because of 18 megabits you got less latency or less packet loss. And you want to evaluate that. I'm going to run faster because I think my time is running out. Stream delivery performance intelligence. I want to gather stream delivery impact on the network performance. I want to check for packet loss, jitter variation, route changes, burst events, things that people overlook. And this is very critical when you're doing JpegXs. When you're doing 2110, those burst losses are critical. Latency changes, protocol, it has to be protocol agnostic. You want to also gather video stream statistics and non-video stream statistics and take a look in that. And you probably want to have multiple alarms and events on that. You then want to correlate those alarms and events to those intelligent information you gathered. I'm going to run very fast because probably Brad will kick me off and I want to go to the path analysis, which I mentioned before. While you are streaming, you want to do path analysis to see what are the changes, if there are service impacting, and these are very important. I'm going to run fast, and why should you care? Today, monitoring tools are inadequate to give you that insight on the video delivery issues. The sample rate is just too big to matter. I'm sorry, I'm running fast. Time is of the essence. Information collaboration between the video teams, the broadcast teams, and the IT teams is critical. Broadcast people starting to talk, have to talk in IT lingo and to bring that information to the IT teams because IT does not speak broadcast. So we need to give them the information so they will understand immediately what is going on. We can't tell them, oh, the ETR is bad. They don't know what is an ETR. Okay? And I want to run fast because I prepared a lot of graphics for you guys. So this is how a system should look like. Basically, we want to explore the data from the source, from the sender to the receiver, identify the multiple paths in between, gather the statistics, and correlate those statistics between the source and the sender. Sorry, the sender and the receiver. We may want to use machine learning and AI to identify trends, to figure out what is going on, and so that we can alert that to the broadcast people, to the IT people, to take note before things are becoming a problem. So let's explore some examples, and I'm going to try. So one example is constantly testing the path. So we want to test the path between two points. We need to constantly monitor the link performance from sender to receiver. Any performance impacting like packet loss, latency, jitter, TTL, and bitrate violations. Detect any burst loss on the source if we see them on the destination, because sometimes problems are in the source. They are not related to the network. They are coming from the source, from our encoder, from our playout system. We want to identify those. And then we want to correlate them to the destination, to the receiver. So then we can match and figure out what is going on. Route changes and their impact on the video. Once again, running fast. We need to monitor it on a packet by packet. We cannot leave it for once every minute or 10 minutes. We need to monitor those on a packet by packet because they will show us that something changed on the network. I can tell you that test that I conducted, I can see variations of 3, 5 hops between packets. And just last week, I saw a complete hiccup on the internet with like 150 hops that happened on a 1-second event on about 10,000 packets. And that, you can't recover that, but you need to know what happened, and it's not your fault or the IT fault. So in this case, we monitor the packet, the TTL, which is a parameter in the packet itself. We periodically scan the route, and we can identify a faulty point if there is one, if it's not responding correctly, and we can let the IT people know about it. Going forward, burst loss and impairments. This is something that we learn that there is salt and pepper loss, burst loss, but we never see that. With intelligence, we can gather the information and see that burst loss, and we can now understand how do we need to set our recovery solution, or how do we do seamless switching with regards to burst loss or whatever loss we have in the system. So once again, we're monitoring everything. And here, for some reason, we are sending another stream, which is at high bit rate, and that bit rate suddenly takes some of our packets and creates a burst loss. We need to identify that rogue stream, that rogue flow, that probably not, we are not the one controlling it. It might be our IT team or somebody else. We need to identify that. I'm going forward. So this is going from the sender, but the same is true on the other side. It can be other senders sending to my destination, and I need to identify that somebody else is creating the problem. I'm the one impacted, but somebody else created the problems. I need to identify that flow and how it is making my stream hurt. And prioritization of flows, which is transient events will touch base on every flow going through, and that will fall short on every delivery system. Once again, I'm running fast, and please excuse me. Basically, we need to monitor everything, and all those transient events need to be correlated, known, so we can have a better system. I think this is a repeat for some reason. I'm running fast. And that's it. Thank you very much, guys. Any questions?
Thank you, Adi.
Kiran, you promised me a question. Kiran, you promised me a question.
Oh, Rick, looks like Rick's got a question. Oh, looks like Rick is, ladies and gentlemen, Rick is walking out. He'll be back. Yes, okay.
I'm not used to having a presentation with that question, guys. Zero. Somebody.
Oh, wait. Here, I'll save you some time.
Okay, so you get all that visibility. What do you do with that information? What knobs can you turn? Because, as you said, some protocols are not adaptive, and no video protocol can take changes in latency, otherwise you take a glitch. So what do you do with the information?
So first thing you do is that you acknowledge you have the information. You didn't have the information before. You had a feeling for something, but you didn't have the information. Now, once you see that happening, you may want to select an adaptive protocol, and that would be the perfect choice to take care of the problem. And it's when your stream misbehaves or your network misbehaves. But more likely is that the network misbehaves because somebody else is misusing that. Whether it's another user in your system, meaning that another stream, another department, or it can be on the other end, other streams, and now you know what it is. You can correlate those artifacts against your stream, and then you can come back and say, okay, guys, you misbehave. You need to set a SLA. You need to set a QoS in your system to allow me to work properly. Before that, and I can say from my experience, it was like, if it involved a lot of pickups, a lot of analysis, a lot of tools. It would take a lot of time to detect those transients. Now that you have the visual view, it's faster for you to do the root cause analysis and decide what is your next step. In my next presentation, that will be over the next few VTrances, I will talk about how we are using that and tying AI and doing the next step in order to detect trends, do it faster, and so on.
Great. Andy, thank you very much.